Hey everyone, I'm Brian Rinaldi. I lead developer relations at LocalStack. I'm really glad that you all are joining us today for our latest monthly meetup. We've got some great talks lined up for you today. Also super excited because, well, it's a very busy day today at LocalStack. We actually just pushed the 4.2 release, so you can check that out and look for more details on that coming up on the blogs and release notes and all that stuff. Won't be covering that today. Today, we're going to be talking about some other cool features. So obviously, this is the agenda. We're in the intro and welcome right now. That's where you are. We've got two great sessions coming up. One is on one of my favorite new features of LocalStack, which is Lambda local debugging of your Lambda functions. You can do step debugging and all kinds of other cool things. So like it just really makes the experience of building Lambda locally just great. And then Harsh will be here to talk about Terraform modules in local and CI environments and using LocalStack for testing those. We'll have Q&A after each of those sessions as usual. You can submit your your questions via Slido. So it's completely anonymous and things like that. So get your questions in as the folks are talking, and we will answer them live here. And then obviously we will end the session with a conclusion, well, whatever that is. Okay, so this is the intro and welcome. We have a slide that tells you you're here in the intro and welcome. Welcome. We're glad to have you here. So these are the speakers today. Obviously, I already introduced myself, but we've got Marco and Harsh as well here to give two really great talks. Why don't you guys introduce yourselves? First, I'll turn it to Marco.
Hello, everyone. I'm Marco. I'm a software engineer here at LocalStack. Recently been involved with the development of our step functions interpreter. And today I'm very, very excited to present to you and share with you our new preview feature, which is the Lambda Debug Mode for LocalStack.
Awesome. And Harsh?
I guess I don't need any introduction. Like I have
You
been,
don't?
I have been
You've
face of
been
these
here a lot.
meetups for years now. So
Yeah, but there might be new people, Harsh.
yeah. So jokes aside, I'm Harsh. I work with Brian at LocalStack. I've been exploring and tinkering with a lot of LocalStack related features, and I'm just excited to talk about the Terraform tests integration because this is something that I'm really passionate about, like infrastructure as code and regular CI/CD workflows. So it is a good topic to kind of bring both of these two things together and kind of showcase a really focused use case story around how you can best utilize that. So yeah, just excited for this and hoping that we can have a really nice conversation around the whole story.
Awesome. Looking forward to both talks. All right. So as I mentioned, there will be Q&A following each of these talks. So you can add those on slido.com. Just go to slido.com and put in this code to put in your questions, and we will answer them live as soon as the presentation is done. So, feel free to add whatever questions you like during the presentation. We'd love hearing from you, and we love answering your questions. So with that, we are actually going to jump straight into our first presentation from Marco. So let's see. Let's have Marco join me back up on stage here. There he is. There's Marco. All right, Marco. I'm going to turn it over to you. You can share your screen, and we'll get started
Right away. So thank you for the introduction, Brian. And yeah, very excited to present and share with you our new latest preview feature, which we call Lambda Debug Mode. Lambda is one of the key components of most AWS stacks. And developing Lambda functions in LocalStack is a game changer for sure. It enables you to have a very fast iterations over different derivations of your Lambda functions. However, debugging has been something that somewhat limited until now. And with this new preview feature, we want to embark on a mission to really give time back to the developer and faster, even faster iterations on developing the Lambda functions through a more streamlined and powerful debugging approach. Lambda Debug Mode is a mode for LocalStack, and it unblocks two major limitations of the current state of Lambda debugging locally. The first thing it does is it takes care of automatically managing the timeouts that are involved when invoking a Lambda function. So of course, this can be a very painful limitation since you need time to connect remotely to the Lambda session to attach the debugger and then run through your process of debugging it. Lambda Debug Mode in LocalStack takes care of all of these the timeouts and allows you to have ample time to connect the remote debugger and debug the Lambda function. And the second thing it does is it allows the developer to debug multiple Lambda functions, which is something that wasn't possible before. And it achieves that by allowing multiple remote debuggers to be connected through customizable ports, which is something you can customize in a config file. So let's take a look at how it looks. And I remind you that this is a preview feature. We're really actively working on this. And there will be definitely stay tuned on this space. There will be major improvements to the usability of this feature. However, it's very important for us to share with you as it unblocks several limitations of today's state of debugging Lambda functions. The first thing that you should do to enable Lambda debug mode is set a couple of environment variables. So here I have a very simple and minimal Docker Compose for my LocalStack instance locally. And you will see I set a couple of environment variables. The first one is the Lambda debug mode set to true. And this instructs LocalStack to start in a Lambda debug mode. So taking care of those timers we talked about before, and also look for the other configuration variable, which is the configuration for your debugging session. So this is a file which you can mount into your Docker Compose container, and it allows you to customize which Lambda functions you would like to debug, and if so, on which remote port. And also some other features like have more fine-grained control on the timeouts handling. You will then need to add some supportive some code to support the connection of the remote debugger. In Python, you will achieve this using this small snippet that we provide on our documentations. However, every programming language does this slightly differently. So definitely take a look at our docs for more insights into how to customize your Lambda function so that you can connect remotely your debugger. This is something that we would like to definitely improve, but for the time being, it makes the feature feasible, and it's a small change that you need to apply in your Lambda function. After having added this needed configuration for the remote debugger, the configuration file for Lambda debug mode is fairly simple. We have a small example here on screen. It's basically a simple listing of the Lambda ARNs and which you would like to debug and which port you would like to connect to locally. So I'm going to jump into a demo of this new preview feature, and I would like to achieve two things in this demo. I would like to show you how we can debug multiple Lambda functions, how the timeouts are automatically handled. And also, I would like to show you how this is a great feature that works well with hot reloading, which will allow us to debug our changes and also make changes and iteratively improve our Lambda function. We will then look at debugging multiple Lambda functions in a more complex scenario, so where we don't have the possibility of invoking the Lambda functions directly from the CLI. And I'm going to achieve this by embedding the two Lambda invocations, the two Lambda functions we're going to debug in a state machine, which is very simple. It takes some input data about some weather sensors. It runs it through a first Lambda function, which runs some validation on these values. If the validation fails, we will then return a failure of type validation failed. Otherwise, it will go on and detect anomalies in these measurements. And if there are anomalies detected, it will fail. And if none are detected, well, then the state machine will finish the process successfully. We will have a couple of bugs to find and fix with hot reloading and remote Lambda debug mode. One will be in the validate sensor data, and the second one will be in the detect anomalies. So with this, let me jump into some code and the demo. So I'll first go onto in my IDE, and this is the Docker compose file that we use to start the LocalStack container. You will see that, as we saw just now, we set a couple of environment variables to make this possible. The first one is we enable the Lambda debug mode, and the second one is mapping the config file to the local config file for debugging the Lambda. So I will go and start this container like this. And whilst that's starting, it's already ready, I will go back. And let's take a look at the Lambda functions that we have. So the first one is here on screen. It takes, let's ignore this code for now, we'll see in a moment. The first thing it does is sampling the normalized data object from the event, and then run some normalization logic. And if there are any issues, it will, such as the normalized data not being available, it will raise an exception. The other Lambda function that I have is the sensor validation, and this, similar to the first one, samples the needed data from the event, does some sanity checks, and goes through the process of normalizing these. So I will quickly get rid of this debugging helper functions, and I will show you my CloudFormation stack, which is very simple. I just want to share with you how we can easily configure the hot reloading. So in this case, following our docs, we simply set the location of a Lambda function in the hot reload bucket, which is a special internal name we use for this feature. And then we set the key of the object in this bucket to be my Lambdas folder. And this is where LocalStack will look for my Lambda functions, and will automatically update the Lambda functions whenever I make a change locally. We then have a short resource for deploying the two Lambda functions. You can see here. And in fact, it's true, we do set the bucket to be the hot reload bucket, and the S3 key to be the folder path that we set as a parameter above. And then finally, we have the state machine we talked about briefly before. So in this case, I'm using the new JSONata and variable features to more easily go through this logic and define my state machine. And you will see it does exactly what we discussed earlier. The first thing this state machine does, it sends a Lambda invoke to the first validation function, validation Lambda function. And if it fails, it will go into a fail state. If it succeeds, it will continue to detect anomalies. And we store the normalized data that we get back from our Lambda function into this variable. The second invocation to the second Lambda function is very similar to the first, and saves any anomaly detected, any errors that happen in the detection of anomalies in the sample data into this anomaly error variable. And then finally, we have the 3 terminal states we discussed earlier. So the 2 failures for either validation or anomaly detection. And then finally, the succeed state. So I will continue by showing you the debug file, the debug config file for our Lambda debug mode. So I only have 2 Lambda functions, and I would like to debug both. So in this file, I ask LocalStack to look for this Lambda function, which is the sensor validation function, and open this port for me to connect remotely to it. And likewise, for the second function, I give the ARN and the port I would like to debug on. Something to note is that if your Lambda function ARNs are not available before startup, well, then this file is also hot reloaded, which means that whenever a change is seen in this file, the Lambda debug configuration is directly applied, is immediately applied to the runtime of LocalStack. So if your Lambda functions come up later, or you would like to debug a Lambda function later during your local emulation, you can jump in this file and apply the change, and you will be able to connect remotely to that. Before I continue, I will just show you how the Lambda functions currently can accept a connection to the remote debugger. So as discussed earlier, we provide this small utility function in which we ask the remote debugger, debug by in this case, the debug client, to connect or wait for connections on the same port we configure in our Lambda debug mode config file. And the other Lambda function very much does the same. So we will deploy the stack now, and you will have seen earlier I commented out the code to this utility function, which means that now if we invoke these functions, they should go through as if we were not debugging these functions at all. And we'll take it from there. So I will go back to my terminal, and I have a small utility that will help me move through this demo. And I will start by deploying the stack. Should take a minute. And then once the stack is deployed, we will try to debug just one Lambda function, apply some changes to this Lambda function, and then debug again and see how this connection of all reloading and Lambda debug mode work well together. So a few more seconds, hopefully. Okay, we're ready. So I have another simple script to invoke this Lambda function. And I will just pass a demo input to it. So if I invoke it like this, we will see that it returns immediately. It does evaluates the logic that it's supposed to. In this case, it returns the normalized data field with the values being normalized. So let's say that now I do want to debug this function. Then the function derivation is being hot reloaded. So I can move in this function, which returns the normalized data. So is this a function exactly? I will now make a change to this function, which will be reflected immediately in the runtime. And I will set a breakpoint right at the start. So my utility function will wait for the connection. As soon as I'm connected, hopefully I will stop this. I will continue debugging from this point. So if I go back in my IDE, in my terminal, and I run another invocation, first thing we should see is that exactly it doesn't return anything. It's basically waiting for us. It knows that we are debugging the Lambda function, and therefore all the timeouts that we normally apply no longer do. If I go back to my IDE, I have a VS Code configuration ready to attach to this port. So I can fetch it from here. Should be this function. And if I connect, I'm debugging the Lambda function. So we can see I have access to a very traditional debugger in VS Code. In this case, I have access to the member variables, local variables, and I can move through the function. I also have functionality to continue like this, and the function returns. If I want to make some changes, so perhaps I want to add a print statement for the sensor data variable, I can write the function, write the change, and if we go back and invoke it again, we should see this change as applied. So in fact, I can debug the changes we just made, which is nice. Okay, so this is us using hot reloading to modify our Lambda functions and Lambda debug mode to take care of any timeouts that might happen or that might restrict us from doing our work at our own pace. Let's see how we can debug multiple Lambda functions in a slightly more involved workflow. So I will go back to not having the debugger connect here, and let's invoke the state machine that will first invoke the validation Lambda function, take the output and pipe it into the normalizer Lambda function, and then bring the outputs together for a final output. So what I can do here is I have a script to help me execute this state machine. So I have a step functions invoke, start, execution, and this will pass the same input as we've seen before. So now this is the state machine starting. I will make a note of this execution on, so we can see what happened to this execution. We can use the get execution history to see exactly what happened there. So it will be a verbose output where we can see that the execution failed. And if we look at the cause message, we see that no sensor data were provided. Okay, so let's see if you can debug this issue in our Lambda functions and address it. So the issue seems to be this exception being raised here, and it appears like this condition is being evaluated as true. However, I'm pretty sure I'm passing the right data here. So let's allow our debugger to connect and see if we can fix it. So for this, I will start the state machine once again. And hopefully we should see that although the state machine is eager to terminate and wait for handle the output of the Lambda function, because we are now working with Lambda debug mode, the state machine should be hanging as we haven't connected the debugger and we have allowed for the Lambda function to return. So we can use again the get execution history for this execution arm. And we can see that the last state says that the task has started and is evaluating the first Lambda function. So yes, it's waiting for us to connect. So let's go back to our IDE and connect the debugger. And here I am. So if I evaluate this step, sensor data is indeed empty, and that explains why the exception was raised. However, why is it empty? So in the environment, I can look at this variable. So sensor data is being provided by the state machine, but we're sampling as snake case instead of camel case. So I will continue this execution and make my change. See if this one gets us anywhere. Go back to my terminal and start execution again. So I left the debugger on for the Lambda function because I want to make sure my fix went through. So let's just make sure. Whoops. No, not now. So I would just want to see that the step functions state machine has paused at the same point. So that would tell me that the debugger is still on. Yes. So the task has started like earlier. So if I go back and I connect again, I'm in debugging this Lambda function, and hopefully now sensor data has been populated, which it is. So let's just continue, and yes, we are returning normalized data now, so no longer raising the exception. Okay, so let's continue, and let's see if there's any other issues with our workflow. So we'll get the execution history for the same state machine. Now we have a different error, so no normalized data provided. So let's go back here, and here's the error. It seems to be on the other Lambda function. So fine, perhaps it's a similar issue as before. I will enable my utility function to connect the debugger, go back to my terminal and start another execution so I can take a good look. Okay, this one has started. So I left the debugger on for the previous Lambda function, so I should connect there and make sure this is still doing what it's supposed to, which it is. Okay, and now if I set the breakpoint on the other Lambda function like this, and I connect to the second Lambda function, okay, so we had an issue with normalized data being empty dictionary. However, this is being provided through the, so it's been provided through the event object, and the issue is the same issue as before. So we use we used snake case instead of camel case. So I'll let it run, continue, come here and make my change, save. Hot reload will update my Lambda function, go back to my terminal, start another execution, wait for this to start. Okay, so I left the debugger on for the first Lambda function, so I can still connect. Normalized data is being returned as before. And let's see if we fix the issue also in this second Lambda function. So now normalized data, yes, is being populated correctly. So this check is no longer an issue. Okay, it will run its anomaly detection logic, and seems like anomalies is empty. So okay, this looks like should go through like I expected. Let's just check the state machine to see what the result is. So looks like we fixed both our Lambda functions using Lambda Debug Mode to debug multiple Lambda functions and allow for the timeouts to be handled for us and give us ample time to do all the checks we need to and all the changes we need to. And we use hot reload to not having to restart LocalStack and apply the changes and iterate through all the fixes we need to. And we managed to fix this this small stack and workflow. So this brings me to an end of my demo for Lambda Debug Mode. Thank you all for following, and hopefully you will continue following this space for this Lambda Debug Mode feature, and we'll be able to surprise you with more ease of use in the future. Thank you.
Great job, Marco. We did have actually several questions from the audience, so let's just go ahead and jump right in. So let's see. First up, does it? So live. My dog's going crazy. We might not hear them. I hear them. So does it support Node.js TypeScript?
Indeed. So we support all multiple languages. The only difference that would take place there is the way in which the remote debugger connects and in which you configure, in which the Lambda function is configured to allow for the remote debugger to connect. In our docs, we do a better job of going through a couple of more languages other than Python. So we have an example demo also for Java and Node, and I suggest you you go on the docs and review the process there to get set up.
Awesome, awesome. Okay, is there a better way of managing the debug client? Seems difficult to manage.
Indeed, this is so it's a preview feature. We wanted to share it with you because we believe it unblocks some current limitations in debugging lambdas. There will be a better way. There will be a more straightforward way. However, for now, the best is possible to do is to configure the debug client to connect to the different ports, which map to the different Lambda functions you want to debug.
Right. I know you hinted at basically ways that you plan on improving the developer experience as we kind of iterate on this feature. So I think that's something we're aware of it being not the easiest, but we're trying to fix. Well, we're working on fixing it, right? Basically.
Yes, we're on a mission with LocalStack to really revolutionize the way developers go about cloud development locally. And this is one of the many features on top of our already great emulators and parity that will make this possible. So stay tuned for significant changes in the space, definitely.
Absolutely. Okay. There was another question. Is there a way to inject the debug? This is basically, I think, we're going on the last question. Is there a way to inject the debug configuration automatically inside of running Lambda?
Currently, this is possible through the hot reloading, which is what I've been using in the demo. So if you know you want to debug a Lambda function that is running, you can jump in the derivation of this Lambda function and add the calls to allow for the debugger to connect. So this is how it's currently achievable.
Right. So, but effectively, just to kind of clarify on this question, I know it hot reloads the Lambda itself, and it'll hot reload that configuration file that you put there with the ports. But it does not. I mean, obviously, you have to set the S3 bucket for the hot reloading during the deployment part. That part you have to do ahead of time, correct?
Correct. Yes. If hot reloading is not configured on startup, then the only other option is to update the state machine itself. But it's definitely less convenient.
Yeah, for sure. And I think there was one other question, if I'm not correct. Okay. How does the VS Code configuration work, and is VS Code mandatory to use this?
So VS Code is not mandatory. You'll be pleased to hear. You can use whichever IDE you prefer, as long as it integrates well with remote debuggers. VS Code basically allows you to define a JSON configuration file, which makes it easier to then have access to the UI elements that connect to the remote debugging. In there, you would just specify which language you're debugging, which library or debugger flavor you're using, and which port to connect to. It's just how VS Code works. But for example, in IntelliJ IDEA, you can use that as well and work with the configurations files. In the docs, we do go through these two scenarios as well.
Great, awesome. Well, thanks, Marco. This was great. I really hope people experiment with this, and I mean, I think going back to the idea of like how we're iterate. This is an early release feature. We're iterating on it. Like, if you do use it, send us feedback. We love to hear from you. We want to improve it and make it the tool that is indispensable in your development. So we your feedback can really help drive that. So thanks, Marco.
Thank you.
All righty. Now we're going to move on to our next speaker, which is already famous among Meetup attendees. He's always here in one way or another. Harsh, go ahead
Except
and
when I'm
tell us
out.
about. Yeah. All right. Looking forward to your presentation, Harsh.
Cool. Thanks, Brian. Awesome. So hi, folks. My name is Harsh, and in this session, I will talk about how you can test your Terraform modules in your local and continuous integration environments with the help of LocalStack. The agenda for this talk would be really simple. We will talk a bit about what Terraform is and the all-new tests framework that was introduced sometime back, I guess maybe a year or maybe a couple of years ago. And we will see like how you can use LocalStack to pretty much test your Terraform configs or modules and more without having to like actually deploy it on the real AWS cloud. Now, as I said before, it's a fun use case since a lot of our users rely on LocalStack for testing and iterating on infrastructure or IAC templates. So we will get on to see like how you can basically use this practically. Uh, so now I suppose like some of you would already know what Terraform is, but just for general purpose, I will quickly introduce you to it. So Terraform is an infrastructure as code tool that basically allows you to like programmatically provision cloud resources. That's all there is to it. Now, the workflow, as you can see in this diagram, it's pretty straightforward. You are a practitioner, so you basically write your configuration files. Next, you generate a plan, basically an overview of all the things that you're going to deploy. And third, you basically go around and apply those changes to create or modify resources. Now, the reason like why Terraform is so popular is because it allows you to like build cloud resources in a repeatable way. It's pretty much like documented. It is something that can be version controlled, and you have got access to all of these provider-specific APIs that are abstracted as plugins. So Terraform is not just logged into one specific cloud provider. You can technically get to use whatever there is to it. So you can deploy on virtual machines, you can deploy on GCP, you can deploy on Azure, you can even like deploy on your own bare metal clusters or servers out there. Like Terraform just works out of the box for everything out there. Now, again, like the reason like why Terraform became so massive right now is because it is technically open source, or maybe it was technically open source, in the sense that now we can just read the code, but their recent license change means that it is now much more source visible than truly open. But again, like that's not our contention. If you're using Terraform or any other alternative like OpenTofu, you can still follow this particular session and you can get to see how LocalStack helps you write your tests against your IAC templates. Uh, Now, as I said before, Terraform tests framework was introduced some time back, and it basically went generally available with Terraform 1.6. And basically what this offers you is that you can now natively test your Terraform configurations without using an external framework or library. Now, this means that you can pretty much like run a single command, which is Terraform tests in this case, and it will execute all of the test files in your setup and just give you like a quick validation whether they work or not. I remember like I worked for the first time on Terraform, like that was back in 2020 or 2021. I don't remember exactly. But back then, like I was simply writing tests against Terraform using a PyTest plugin. I guess that was the Terraform PyTest plugin that was built by Cloud Custodian folks. But it was basically doing like a lot of abstraction for me. But now I can pretty much do whatever I need without needing any sort of an extra tool. But maybe apart from LocalStack, because that's what we are going to talk about. But long story short, you can basically use this new Terraform tests framework to basically like write two kinds of tests. The first one are the unit tests. And this basically allows you to like write and verify your resource configurations. So just imagine you're writing a Terraform config that is setting up some S3 buckets. So you need to check if your S3 buckets are correctly named, or maybe you need to check if your load balancer configurations are set up correctly. So this is exactly where the test framework basically perform the unit testing in. The next step and the second option is the integration testing. And what this basically does is like it ensures a proper interaction between different resources out there. Now, this is like a really fun use case, simply because that like with this setup, you can basically like deploy an app to a server, and you can basically check if that app has been properly deployed and configured. Now, depending on whatever your use case is, you can use either. But for this demo, we will just focus on both of them and how they exactly work out. So this is a really basic, maybe like a simple hello world example that I really wanted to showcase on how you can like write Terraform tests. So if you're setting up Terraform tests, you just like need to know that Terraform discovers test files inside your configuration by checking for these two extensions. So if you're like setting up a Terraform test file, all you need to do is set up these file extension, which is .tftest.htcl and .tftest.json. So just go ahead, create a directory called as tests, and you can basically add your file with .tftest.htcl if you prefer going the HCL way of writing your tests. And I'm speaking this with all seriousness that I don't know anyone who would simply go with the JSON option of writing the tests. So just do not venture into that territory. But again, like every test file that you basically write have got some root level attributes and some blocks. Maybe what I can do right now is maybe turn on the pen so that it's much easier to kind of talk about. So the first thing that you will notice is that we have got this particular block called as the variables. Now, this is very important for us because this is where you define the variables that is required for your test. You can always define as many variables as you want. Next up, we have got something that's called as a run block. And for now, I would like you to focus on this particular assert block over here. But maybe for this one, we will focus on that a bit later. But just talking about this particular thing, like about the run and what the assert does, is that this is basically where we like define our assertions. Now, what these assertions do is like they basically check a condition, and if it has failed for some reason, it will basically log this in the output. Now, just remember that you can have optional variables inside this run block if you'd like to use these variables inside those assertions. We don't exactly need that right now, but in our example, we may see some of these examples out there. So from this hello world, I guess one of the crucial things that I missed out, but that's completely optional, is defining a provider block. And this is where you can specify your Terraform providers. You can set up the region that you want to test in and all of these things. So you can basically set them up as and when you need it. But right now, that's not needed. But we will look onto that like once we see our main demo. So with that said, I guess what we can do right now is like maybe let's do a quick start and take a look at how we can like write a Terraform test for a very simple use case. What I'm going to do is go around, create an S3 bucket using Terraform, and I just want to test if it has been set up correctly or not. So I'm just checking on the time right now, making sure that everything is fine. Yeah, everything is fine. So what I will be doing now is I will be switching to my GitHub Codespace. For people who are not initiated with this, GitHub Codespace is just a cloud-based IDE that I'm using. The reason I'm using a GitHub Codespace right now is because it gives me an ease to switch between different tabs rather than sharing my whole screen. That just messes up the whole resolution. So what I can do now is I can go ahead and maybe create my Terraform configuration file. So I'm just setting up the main.tf in this case. And what I will do is I will ask GitHub Copilot, because this is the age of AI now. I'll ask GitHub Copilot to kind of just write a Terraform configuration for me. So I'll say create an S3 bucket. Let's say maybe named like LocalStack Meetup, because we are in one of these meetups now. So as soon as we do that, okay, that's not exactly what I was expecting, but maybe let me just give it a prompt. And as you can see, like it was able to use the AWS S3 bucket resource. It was able to set up the bucket that's named as LocalStack Meetup. I don't need this ACL right over here because I'm just demonstrating a very simple use case. So this is exactly a basic hello world kind of a Terraform example. And what we can do right now is that we can actually like try to write a test against it. So as I said before, the first step that you need to take is go ahead and create a tests directory. That's exactly how it is going to look like. Awesome, we have now set that up. The second step, and this is where we will be asserting that our S3 bucket is named in the correct fashion. So what I'm going to do is create another file inside this directory, which is called as assert.tftest.htcl. And as you can see, like I'm pretty much like writing all of my tests in HashiCorp configuration language. Maybe it's just me, but like for writing general IC code, okay, HCL looks great, but for writing tests, maybe it can be slightly tricky to kind of work with. So hopefully my session would be able to give you some sort of an insight onto how this works. So as I can go back to my example and like show you again, what we first needed is a run block. So let's go ahead and kind of create a run block now. So I'll specify the run block and I'll specify what exactly I'm trying to do over here. So it is verify the S3 bucket. And I'm just going to like create this block over here. Once that is done, I'm going to set up a command in this case. Now, this is one of the options that I did not explore before. Someone who knows Terraform in and out, maybe you can post it on the YouTube chat, whether like what it basically implies. But maybe I'll just talk about that a bit later. Okay, so now I've set up the command, which is plan. And what I can do right now is I can create an assert block. And this is what it will basically look like. And in this case, we will set up two things. The first one is going to be a condition. So we will set up the condition, and this condition will basically imply that, hey, we have the S3 bucket resource. We have the LocalStack Meetup resource, like the bucket name in that particular resource should be LocalStack Meetup itself. So maybe like I can just type that out. So AWS S3 bucket. I'm just hoping that the Copilot can kick in, and yeah, it did kick out. So LocalStack -meetup, that's exactly what we defined over here. And it is specifying the name of the bucket as LocalStack -meetup. Okay, looks sweet to me. One thing that we missed out is setting up an error message. So what would the Terraform test will basically log if in case like our test configuration has failed. So we will set up an error message. And in this case, the error message is just going to look like something like this, that the bucket name is not correct. You can just customize it as the way that you basically need this. So this is exactly what like a hello world like Terraform config would look like. And this is what a hello world test config would basically look like. Now, I have not introduced you to LocalStack yet. That would come on the later slides. But I have already started LocalStack in the background because I need to hit like one or two AWS APIs out there. And if I wanted to do that without LocalStack, I would have to set up my AWS credentials. So what I can do now is I can go the usual way. I can go Terraform init, and I can just go straight to Terraform test. So let me just run this right now. So Terraform init. And this is going to install all the dependencies, initialize the provider plugins. That is going to take a few seconds now. And yes, this is done. Okay, awesome. And what I can do in this case is just run Terraform test. Now, when we run Terraform test, the whole framework is going to just take care of all of the things for us. It is going to initialize, like not initialize, but it is going to like plan those changes, because in this case, we have set up the command as plan. And then it is going to make sure and assert whether the bucket name was set up correctly or not. So let me go ahead, set up Terraform test. I hope the demo gods are with me. And this would take like a few seconds. But if you go onto the LocalStack logs, you see like I have just managed to like hit one API endpoint, and that was the get user. I'll explain like why I had to like set this up later. But for now, we can go back and we can get to see that our test config has passed. It is success, and one of the tests has passed. 0 of them have failed because we didn't have like any more tests out there. But this gives you like a very necessary insight into how Terraform tests basically work. That's all you need to do. You need to set up your Terraform configs or modules. You need to set up the Terraform tests. You need to set up the appropriate command. It is either plan or it is apply. And then you need to set up proper asserts or a proper module if you are looking for use cases that's beyond unit testing. Now, just going back onto this, and let's maybe go to the next slide because we missed like one of the crucial things. So when you notice, like I was writing that particular code, you would have noticed that I used a plan command. Let me just go back and show it to you again. So this is where we use the plan command over here. I do not see anyone who has mentioned like why I mentioned this plan command. So I can do that explanation myself now. So what it is basically doing is like it's very, very similar to the Terraform plan command. And I guess like this is something that most of the Terraform users will already know. So this approach does not technically deploy or actually provision any sort of an infrastructure. It just like lays out a map or a plan of what exactly your Terraform config is going to deploy. And internally, this framework will just use assertions to verify if the configuration produces the expected values. This basically means that if I'm setting up S3 buckets or name of Lambda functions, it would be able to like give me the right values. I can basically like write tests against that. But what if you wanted to write a test that validates if a Terraform configuration produces an expected ARN of a Lambda function? That will fail out because you cannot like get the expected ARN of a Lambda function unless and until you actually deploy that Lambda function. So this is a reason why unit testing pretty much goes well with this plan command. But in contrast, if you want to run like integration tests, this is exactly where you should be using the apply command. This is very similar to the Terraform apply command again. So this apply command, what it basically does is like it deploys an infrastructure and then it checks the whole functionality. So when you actually like write integration tests with the Terraform test framework, what you usually do is like you use data sources to validate expected responses from deployed resources. Now, that's basically a way to get information defined outside of Terraform, but that may be defined by another Terraform configuration or maybe by some external user altogether. So if you want to run integration tests, all you need to do is like switch that command attribute to apply. But that would also mean like you're deploying to the real cloud, basically some sort of a live infrastructure. And as like the general theme goes around LocalStack, it's like deploying on real cloud is obviously costly and it is going to be time consuming. Like cloud is pretty great for all sort of like resilience, scaling, security, the kind of like infrastructure that you need when you're actually reaching out to real users. But just think about what you really want to give to your developers for something to just develop and test against. For example, if you are setting up a Terraform config with a bunch of load balancers, Lambda functions, EC2 instances, and all of those things, you cannot like have your developers like kind of deploy against the real AWS cloud for every single change that they are making. That is the reason like on this particular graph, you see that with each level in this pyramid, it gets slower, it becomes more expensive. But hey, there is a way to cut that down, and this is exactly where we get introduced to LocalStack. I'm pretty much sure that a lot of people on this meetup would already be aware about what LocalStack is. But just to give like a very high level overview, LocalStack is basically like a local cloud development platform. And at the center of it, there is a core cloud emulator, which powers over 100 plus AWS service. Like the main goal of LocalStack is to basically give you an easy on-ramp into AWS. So for example, if you have a Terraform configuration or a CDK stack or whatever that is, we should be able to help you deploy that on your local machine with the experience of just flipping the switch. You don't need to do a lot of extra configurations. You just like need to run one command and that's pretty much it. And with that, we want to enable pretty fast local dev cycles. So you can pretty much iterate on whatever infrastructure or code logic that you have, and you can easily test integrations with your ISE framework. And again, we are not here to like replace, but basically complement those staging environments that you might be having run on AWS. So just to like explain this in a more graphical fashion, like this is exactly what a traditional dev flow works like. So if you are like building on Terraform, you might have like access to an AWS sandbox or a developer account, or maybe like straight up on the production account that you're using for your regular deployment stuff. So whenever you like write some new code, you deploy against that, you test against that, and you finally promote that onto production. Now, what we basically do is like LocalStack adds these additional layers that allows you to do some local development and some CI testing to make sure that you are confident in the set of changes that you did. And your team can also collaborate on those changes and make sure that they work pretty fine before you actually put it out on the staging. Because let's just agree on this one thing, like staging environments can be a bit pain because every single developer wants to get hands on one of them. So if there is one developer who's using staging right now, the other developers are blocked. And we basically want to mitigate that. We want to make sure that every single developer has a local cloud sandbox that they can pretty much run on their laptop and that they can use for testing and deploying and doing whatever the heck they want with their cloud configurations. So it's not a full replacement for staging, but it definitely is something that can at least help you figure out 80% of the issues with your infrastructure code and allow you to like basically fix them up before you can actually test out the real deal on staging or on the production. So talking about the Terraform integration, like we basically offer the TF local, which is like a wrapper on top of Terraform itself. And this is basically like using the same set of commands that the Terraform CLI employs. So if you're familiar with like using Terraform init, Terraform plant, Terraform apply, if you want to deploy the same thing on LocalStack, all that you need to do is set up TF local init, TF local plant, TF local apply, and that's pretty much it. So if you have like the Terraform CLI installed on your machine, you can just go ahead and do a pip install terraform-local, and you would be able to like set up TF local on your side. Just in case you don't prefer to use TF local, you would have to basically set up a provider configuration like this, where you have to specify the access key, the secret key, the individual service-specific endpoints. But again, like you won't want to take on the pain of like writing the endpoints for over 100 services. If that appeals to you, then that's your forte. But otherwise, we would definitely suggest you to go ahead with something as simple as using TF local, at the burden of like just adding one more integration to your toolchain. So in this case, the Terraform integration tests with LocalStack would basically run the very same way that I kind of showcased before. So instead of like using Terraform tests, all that needs to be done is like kind of using TF local tests, and that is TF local test, and that's pretty much it. But there are some extra steps that you need to do if you want to like run integration tests against that. So in this case, what you need to do is like you have to use modules. So we need to use like a setup module that deploys our core infrastructure, like our EC2 instances or the Lambda functions or the ECS task. And then we need to employ like a loading module that performs some functionality to check if it has been set up correctly. So for example, if you're setting up an EC2 instance with an app running on it, you would be like using the setup module to like deploy that infra, but you would be using a loading module to validate that infra. So let's take a look at the demo at hand and see like what exactly I wanted to demonstrate. It's gonna be quick, long and short, will take about 5 minutes. So let's jump right into it. So that's a demo that I will be showcasing. It's a pretty simple serverless workflow. And what it is doing is like it is resizing those images that we are uploading to an S3 bucket. So what we have configured over here is like a couple of S3 buckets. So we have like got an original bucket over here, and then we have like got a resized bucket, and between them is sitting a Lambda function. So every time we upload an image to this original S3 bucket, what it will do is like it will send a notification to this Lambda function that's running, and it will like do a resize operation. It will basically like reduce the size of that image, and it will put the resized image to another S3 bucket. So we will be deploying this infrastructure using Terraform, and we will basically use LocalStack to deploy and test it locally. So let's go to my like GitHub code space and just take a look at what exactly we are setting up. So this is what my Terraform config basically looks like. So as you can see, I have like got like this Terraform config that sets up a couple of S3 buckets, a Lambda function, and then the S3 bucket notifications. That's pretty much that's there to it. But the more interesting part is in our test directory. So as you can see, if I just scroll up, I have got like these two directories over here. I have got this execute subdirectory, and I have got this verify subdirectory. So let me just quickly explain what they are technically doing over here. So in this execute subdirectory, I have got like this main.tf file. And in this case, I need to set up like a provider block because like I need to make sure that it hits the real LocalStack endpoints and not tries to go to the real AWS cloud. So in this particular case, what I'm basically doing is that I'm uploading an image to the S3 bucket that should be able to trigger a Lambda function. That's pretty much what I'm doing over here. So that's a part of the execute. But in this verify module, what we are basically setting up is that we are like using this whole AWS S3 bucket object resource over here. And then we basically retrieve the resized image from this resized bucket that we have. And we technically want to ensure that the Lambda function has processed and it has uploaded the resized image. Finally, we have got this integration test file, which I have named as integration.tftest.htcl, so that I can mark it different from this assert file that I created just to verify the name of the S3 buckets and the Lambda function's ARN. As you can see, like I've set up the command to apply in this particular case. But going back to the integration file, I have like got these different module blocks. And in this case, what I'm basically doing is like I can specify all the variables, the names of the original bucket, the resized bucket, the image path, the image key, and all of these things. And then I can point them to these module paths so that the Terraform test framework would be able to execute them. So yeah, that's the long and short of what exactly there needs to be done. And what we will be basically doing is deploy the primary infrastructure using this main.tf that we specified before. Then we are going to upload an image to the original S3 bucket. We're going to be waiting for 10 seconds because that's exactly what we configured in this verify file, because I really want to give the Lambda some time to make sure that everything is set up on its side. And once those 10 seconds are complete, then we can verify whether the image exists in the resized image bucket. So let's go ahead. Let's first start maybe the local stack container. In this case, I'm going to be doing local stack start. Since I'm going a bit over time, I will try to rush it fast. But local stack is ready. And what I can do now is I can just go ahead and I can just run like tf local test. So all of these run blocks are pretty much like run in a sequential fashion. So you will first see like these assertions will be technically run first in the order. And next, we are going to be seeing like those integration tests running and making sure that the image is getting uploaded to the bucket. We get to verify if those images are present, the resize operation is successful, and the resize image is right now available in the next S3 bucket. So this might take like a few seconds, but what I can do right now is like maybe I can switch back to the slides just in the interest of time. But I can like show you at the end that, hey, everything has been pretty successful. So yeah, the whole setup that I kind of showcased, you can pretty much replicate that on continuous integration environments. So LocalStack has already like got plugin support for GitHub Actions and Serverless CI, and you can like pretty much set up LocalStack as a Docker image, like on GitLab CI, Jenkins, Bitbucket, or whatever the CI provider you're using right now. So whatever the workflow that I kind of showcased over here, like setting up TF local, running the TF local test, and kind of validating how the whole infrastructure gets deployed and tested, you can pretty much replicate and see all of that even on your CI runners. This is pretty instrumental because now your whole team can like collaborate on a single ISE template or templates, and you can basically make sure that whatever changes or whatever commits are being made to the central module or central configuration, they are being validated, they are being tested by LocalStack before you actually go ahead and merge them out. So as you can see, like in this case, yeah, maybe I should share the screen. Yeah. So as you can see in this case, all of the tests have basically passed. You can basically ignore the warnings over here, but all of the tests have passed over here. And in this case, you can see that it was successful. 5 of the tests passed because that's the exact number that we defined. And none of the tests basically failed out. If you see the local stack logs, you can technically get to see like all of the resources that were basically deployed, managed, and then destroyed. Because once you run Terraform tests, those resources are sequentially destroyed again, so as to make sure that you don't have like any lingering resources available in this case. So as I was saying before, you can deploy the same setup on like GitHub Actions. You can ignore that GitLab CI logo on the graphic before, and you can like pretty much replicate the same kind of workflow that you had on your local machine. So just to offer some closing notes, like local stack for Terraform is a like really strong use case, and perhaps the one use case that I've seen people like interacting and using a lot. And based on whatever interactions that we have had with some of the users out there, local stack has been able to like consistently like reduce the whole development environment loop, basically allow the developers to shift left in the whole development process, and also try to make sure that it is able to cut down a lot of the development costs that you usually see. So there are some numbers out here. You can take a look at that. You can try replicating the same setup on your side, and you can see like how much LocalStack has made your processes efficient. Testing to infrastructure locally is a very big use case because it basically allows you to like catch any sort of defect sooner, because you don't want them to land on production and basically create like a huge like headache for you. So whatever you're using right now, it is either Terraform or CDK or CloudFormation, try to make sure that you have a validation layer with LocalStack where you are able to like just figure out how it is basically being deployed, how you can test this, and how you can make sure that the whole team can collaborate on this. And finally, you can like use some local stack tools out there for more efficient workflow. For example, you can use CloudPods in this case. Okay, sorry, I was not sharing my screen. I just realized it right now. But you can like basically use CloudPods in this case. And what it will basically help you do is like, it will help you store your resource state. So for example, if you have like a big Terraform module or a config, and you're like spending about 5 to 10 minutes every single time to like deploy that, you can save that as a CloudPod and you can store that on your end. And every time you need to like run some tests against that, you can just restore that CloudPod and you can run those tests. So it is a pretty efficient way of like making sure that you can cut down the development and test time instead of like just having to provision the infrastructure with every fresh local stack run. We also have like a feature called as an IAM policy stream. So one thing that you might have noticed in my previous example is that I didn't specify any IAM configurations. This is something that needs to be done before I move to production. But there is a feature called as an IAM policy stream that basically allows me to do that. So use this feature, generate all of the required IAM policies, set them up in your Terraform config, and you would have a production-ready setup that can go onto the real cloud. So yeah, that's pretty much the long and short of it. You can check out the blog on which this whole slide deck was based. So you can scan this QR code, or you can just go onto the blog.localstack.cloud, and you will find like my blog in one of the featured ones, I guess, under the tutorial section. So check that out, and yeah, try this out and see how this LocalStack can help you out in your end-to-end use case. And maybe I can take up some questions right now, but if you'd like to catch up with me, you can reach out to me on any sort of socials. And yeah, feel free to join our Slack community, because that's a place where all of the cool local cloud developers hang out. So yeah, that's pretty much my whole session.
Yeah, we're both there, so that's
Yeah.
all the cool cloud developers are there. So
Exactly. Yeah.
that was
Sorry,
great,
Brian.
Harsh.
It was not short. It was not short.
It was yeah, for the audience, like Harsh was like, oh, my presentation is really short. Like yeah, it was not short, but that's okay. That's okay, because I had a lot of really good information in there. So, and I think like one of the things that this is one of those areas where when you talk to developers, they're like, this saves me so much time, right? Because these tests, if they're deploying to AWS, like we didn't really go into the full scope of the application you were doing. But I mean, if you were trying to deploy this to AWS, it would have taken a really, really long time to run those tests. And you were able to do it in just a couple minutes here while we were watching. So, all right. We did have, I think, a few questions from the audience. So, yeah, one was about using OpenTofu with LocalStack.
I guess that's an interesting question, because I promised to kind of cover that in the initial part of my presentation, but I didn't really cover that because I wanted to rush at the end. But as I mentioned, like TF local is a wrapper over the Terraform CLI, or basically the Terraform binary. So OpenTofu, or basically the tofu binary, is also distributed out. So what you need to do is just configure TF local with like this configuration variable that I'm pretty sure like I'm remembering it correctly, but this is TF_CMD. And you can technically point your Terraform binary to the tofu CLI instead. And the usual workflow is the same. You can just use TF local init, TF local plan, TF local apply, and that's exactly going to work the same way, just like the Terraform CLI.
Awesome. Okay, so we've got one more. Well, I think we have a couple more questions, so let's go through those. Where can you find more Terraform examples?
Okay, so that's a pretty good like question, because you can like technically go to our LocalStack samples GitHub organization, and you can find all of the samples present right over here. We try to cover as many use cases as possible, so you can technically just take a look over here, and you can see like how does LocalStack work with Terraform. I will drop this link on the YouTube live chat, and this will be available later in the YouTube description, so you can feel free to check this out. However, I would like to note that Terraform, like LocalStack, wants to be in parity with AWS. So whatever Terraform config you have, you should be able to technically deploy it against like LocalStack as well. So do not wait for an example from us. If you have a Terraform config, deploy it against LocalStack and see how exactly that works out. If you encounter any bugs or quirks, just let us know about this, join our Slack, and we'll be more than happy to help you out.
Great. All right. I think there was one more question, if I recall. Let's see. What's the it was about exactly. Resource I have some resources deployed via different IAC that I don't manage. Can we deploy that with LocalStack?
Okay, so this is like a pretty interesting thing, because we just like put out a feature that exactly solves this use case today. So as Brian was mentioning about the 4.2 release, and we'll try to make sure that the team who built out this feature should also like get on this meetup someday. But we have like just pushed out a feature that's called as the AWS replicator. Maybe what I can do right now is like, maybe I can just share my screen real quick. Let me see how I can do that again. Yeah, just add it to the stage. And yeah, this is the AWS replicator feature that we have just put out right now. And what like the primary use case that it is kind of solving is that a lot of the development teams might be using infrastructure resources that may have been created by someone else altogether. So you might have like stuff like VPCs or SSM parameters or Lambda layers, Lambda functions, or things like that. So with like this new feature, what we are basically able to do is like you can technically pull them on your local machine. You can replicate them on the local machine, and you can have them interact with your regular local resources that you have just created. So I'm not sure like what exact resources you have in mind. Maybe you can go ahead and take a look at this documentation. I'll put a link onto the live chat. But you can go over here and you can like see all of those supported resources. Right now, the coverage is limited to like a few of them out here, basically VPCs or security groups, subnets, KMS keys, Lambda layers, and all of these things. But if you have like more use cases, reach out to us, and we will try to make sure that you would be able to like replicate them alongside your other local resources, and you can like pretty much like work on them pretty much independently. But stay tuned like for a future meetup or a blog coming on the topic, and I guess we will be able to go into more depth with that. So yeah, that's all there is to it.
Yeah, I'm really excited about that feature because I mean, I know we developed it essentially to address a pain point developers were coming to us with, which is like, oh hey, I've got these secrets or VPCs and stuff like that, that like I don't manage, but I need to be able to test properly, right?
Yep.
Like so
hmm
now it's just a matter of like just run the replicator and you're good to go.
Yeah.
So yeah, really excited that we got that got that launched. All right. So I guess that's it for our questions, I believe. Yes. Okay. So we are that's it for our questions. That's it for the meetup this month. Let's see, I'll put up. So just a big thank you. We really appreciate you attending these meetups, whether you watch them live or you watch the recording. So we love to kind of engage with our community. So we'd hope that you will either engage with us on YouTube or preferably even join our Slack and be a part of our community in between these meetups. That's where we're kind of constantly chatting and bringing up questions and things like that. So again, look for the 4.2 release details on our blog today. And with that, we'll see you next month. Bye.